Flare On is a reverse engineering competition that happens every year. In 2022, we had the 9th edition and the challenge number 4 was called Darn Mice. This time, we are dealing with a console application and our input is just one exe file. Running it, it does not produce anything though. Something is shown on the screen if we provide a parameter, but it doesn't leave us with much info before we start. Inside Ghidra, let's pick an entry point as our start. Next function looks a bit more complex, but we can identify main function by looking at the return value. Our next stop is 4011DO. Here, we can help Ghidra in recognizing the correct signature, renaming param1 to argc and param2 argv, but also retype it to char pointer pointer. With that, we can see why we did not get any output if we don't provide any argument. Our program just doesn't do anything if we don't give it. Our next stop is function 401000, keeping in mind that we pass to it what is provided to the program as an argument. Here, the first thing that is noticeable is local2c array. It's being populated with a bunch of interesting looking bytes. We don't know what those bytes are, but they do look suspicious. Before we start looking more closely to the function, let's rename param1 to input. Next, we can see function 401240, few calls, that takes string as a parameter. We saw those being outputted to the screen, so this might be some kind of print function. Let's give it such name. Next, length of our input is calculated. If it's equal to 0 or longer than 23 characters in hexadecimal, we print no, never mind. Let's verify that with the binary. In other case, you leave the room string is printed and we can see a for loop. The index variable name is too long. Let's rename local30 to I. The body of the loop is interesting. First, we allocate some memory using virtual alloc. Then, we take a byte from our input and from the local2c array. We add them together and store it in the newly allocated memory. Then, we treat that byte as code and run it. If we successfully return from such call, we print nibble. When we finish the loop, we print when you return and pass a lot of input to function 401280. If we go inside it, we can see some calls to crypto functions, so this might be code that will decode the flag for us. Back to our loop, how we can make this code work. If we put random byte as code, it will potentially execute, but then we won't return back to our code. How can we make this code do execute and at the same time make sure we return to our loop? And also do all that in one byte? We will just use red opcode, C3 hex. So to do that, we need to calculate what input we need to give to the program so that when we add it to our local2c array, it will produce an array with nothing but red opcodes. Let's summarize what we know. We have our input and we add to each element byte from local2c array. And in each loop, we jump instruction pointer to this area and we try to execute. If we happen to do that for all the values, we get the flag. Jumping to interactive Python for a moment. Let's start by defining an array with bytes that are in the binary. That's one of our inputs. Since program adds byte from our input and from local2c array, and we want to have C3 as an output, we can subtract from C3 a value from local2c array. And we do all of that using Python's list comprehension technique. Nice one-liner. Let's see what will be our magic input when we run the function. We run the binary, providing the input, and in a moment we get the flag. next challenge is ahead of us.